Welcome to the Deep Dive. We're doing something pretty different today. We're diving into Java arrays. But we're not opening a textbook or anything like that.
Ooh.
Our source material is actually kind of cool. It's an imaginary conversation between Mike Tyson and Muhammad Ali.
Really?
Yeah, and get this, Iron Mike is the coding student.
Wow.
And Ali, he's the tech mentor.
It's pretty amazing how they took a technical topic like Java arrays and made it fun and relatable, through this fictional dialogue.
Yeah.
Ali, with his boxing metaphors and his wit, he breaks it down for Tyson and for us, the listeners.
Okay, so walk me through it. How does Ali, the boxing legend, explain Java arrays to Tyson, who's more familiar with, jabs and uppercuts?
Well, he starts by comparing a Java array to a boxer's combination of punches.
Oh, okay.
Each punch in the combination, like a jab or a hook, it has its specific place, just like each element in a Java array does.
Yeah, I see where you're going with this.
Right.
So the type of punch would be like the data type in the array. And the number of punches in the combination would be the size of the array.
Exactly. Ali explains to Tyson that you have to define the type of data that the array will hold, like integers if you're working with numbers, and also specify the size of the array. You know how many elements it can store? It's like a boxer preparing for, say, a 5-round fight.
Yeah.
They know how many rounds they're going to be in their boxing.
Makes sense. So how does this, translate into actual Java code? I'm a little rusty on my programming.
Well, Ali gives Tyson a simple example. Let's say they're tracking the number of jabs Tyson throws in each round of a 5-round fight. Ali shows him how to declare an integer array, they call it jab count, with the size of 5.
Okay.
And he uses this code, int jab count new in T5.
That seems pretty straightforward.
Yeah.
So now they have this array set up to hold the jab count for each round.
Right. Yeah.
What's next?
Well, now comes the action, filling up the array. Each element in that array needs a value, representing the jab count for each round.
Okay.
So he shows Tyson how to assign values to each element, using code like jab count 0 creates 10, where 10, in this case, represents the number of jabs Tyson threw in the first round.
Wait, hold on. Why is the first element at position 0? Shouldn't the first round be at position 1? That seems kind of odd.
Yeah, that's a great question, and it's something that trips up a lot of new programmers. Ali points this out to Tyson that in Java and a lot of programming languages, array indexing starts at 0, not 1.
Oh, okay.
It's like the ground floor of a building, being labeled floor 0.
Oh, okay, yeah.
You get used to it.
You get used to it. So they've declared the array, they've assigned the values, and Ali has, clarified this this zero-based indexing thing.
Right.
What else does Tyson need to know?
Well, next up, Ali introduces Tyson to the length property. He compares it to a boxer's reach. Just like a boxer knows their reach, a programmer needs to know the size of their array.
Okay.
So Ali shows Tyson the code, jabcount.length, and that would give them the total number of elements.
Got it.
Which in this case is 5.
So remembering that length tells you the size of the array that helps you avoid going out of bounds, right?
Right.
Like a boxer knowing their reach prevents them from overextending.
Exactly. It's super important, for working with arrays effectively.
Yeah.
Now, let's say Tyson wants to see the jab count for each round, right? How do you actually work with the individual elements in the array?
Yeah. Yeah, it's not enough to just store the data. You got to be able to retrieve it and do something with it.
Right. And that's where looping comes in. Ali teaches Tyson a couple of ways to go through the array and see the jab count for each round. One is the traditional for loop, which goes through each element, one by one, like analyzing your performance after each round of a fight.
Okay, so that seems like a logical way to do it. What's the other method?
Ali also describes what's called an enhanced for loop.
Okay.
Which he says is smooth and efficient, like his shuffle. This one's more elegant, It goes through each element without having to deal with the index directly.
Okay.
Yeah.
So they have 2 ways to work with the elements in the array. Now, what happens if, Tyson decides to add another round to his training regimen? Can they just, add another element to the existing jab count array?
That's where Ali emphasizes a really key limitation of arrays. He explains that once you declare an array with a specific size, that's it. It's fixed.
No.
You can't just add or remove elements, like you might with your training schedule.
That seems like a big restriction.
Hmm.
What if Tyson decides to, I don't know, prepare for a 12-round championship bout? Or array's just not the right tool?
Well, Ollie reassures him for situations like their 5-round example,
Yeah.
arrays are perfect.
Yep.
But he also mentions that if you need more flexibility, you might want to consider another data structure, something called an array list, which lets you change the size, on the fly. It's like choosing the right boxing gloves, right? You need the right tool for the specific fight.
Right, yeah.
Yeah.
Knowing the strengths and limitations of the different data structures is key.
Yeah.
But wait, before we move on, there's also a coding challenge, right? Our listener didn't just tune in for boxing metaphors.
You're right about that. Our source material includes a coding challenge that puts these array concepts to the test. Think of it as Tyson's sparring session, after he's learned the basics from Ollie.
Okay, I'm interested. What's this challenge all about?
The challenge is to create a Java program that takes two numbers and an arithmetic operator, like plus minus from the user,
Okay.
performs the calculation, and then it stores the result in an array.
Okay.
And here's the twist.
Oh, there's the twist?
Yeah, the array can only hold the last 5 calculation results. So if the user performs more than 5 calculations, the program needs to manage the array, making sure it only stores the most recent ones.
Ah, so it's not just about understanding arrays, it's about manipulating them dynamically. It's like a boxing ranking. Only the top 5 contenders stay on the list. I'm eager to see how this is solved in code.
Well, before we get into the solution, let's do a quick recap of what we've learned so far about Java arrays.
Sounds good to me. Let's make sure our listener has a good handle on the basics before we jump into this challenge.
Okay, so quick recap. Java arrays, they're kind of like a boxer's combination. Each element has its place and its type.
Right. And we know how to declare an array, assign values, and oh yeah, indexing starts at 0. That was interesting.
Right, like that ground floor quirk.
Exactly.
Yeah.
We also learned about that dot length property, which tells us the size, like a boxer knowing their reach.
Mm-hmm.
And those 2 ways to loop through the array, the traditional for loop, like analyzing each round, and then that enhanced for loop. Super smooth, like Ollie shuffle right.
Yeah. Exactly. And a key point, Ollie pointed out that once you create an array, the size is fixed. Can't just change it. If you need to, you got to use something else, like an array list.
Right. But, for our 5-round jab tracking example, a simple array was perfect.
Exactly.
But now we're moving on to this coding challenge, right? Create a program, does calculations, stores the last 5 results in an array.
Yeah, let's break it down. The provided Java solution, it starts by setting the array size to 5. Means it can only hold, the last 5 results. Then it declares this integer array called last 5 result array, and that's where the results will be stored.
Okay, so far so good. It's following the same principles Ollie was explaining to Tyson.
Right.
But how does the program decide what to store? There could be a ton of calculations.
Well, that's where the user input comes in. The program uses something called a scanner object.
Okay.
That reads input from the console, like the user types it in, they enter 2 numbers, and an operator, like plus or minus.
So it's interactive. That's pretty cool.
Yeah. And then the program uses these if-else-if statements to figure out what to do, based on the operator. Plus sign, it adds. Minus sign, it subtracts.
Basic math.
Yeah. But the challenge, remember, is only saving the last 5. How does the code handle that? Well, it uses this variable I.
Okay.
Keeps track of the current position in the array. So each time there's a calculation, the result goes into last 5 result array at the index I. Then AI is incremented, moves to the next spot.
But what happens when the array is full? You can't just keep adding.
That's the key. The code actually has a check to see if I has reached the end. If it has, and the user wants to keep going, the program has to do something.
So it's like the array is a boxing ring, only 5 fighters can be in it at once. What happens to the fighter who's been in there the longest?
Exactly. There's this for loop, shifts all the existing elements 1 position to the left, like a queue moving up. This bumps the oldest result out of the array, makes space for the new one.
It's like a rolling top 5 ranking. That's really smart.
Yeah. And then the index, I, is adjusted, so the new result goes into that empty slot.
That's pretty elegant.
It is.
Takes a complex problem, solves it with, a pretty clear approach.
It highlights how even simple concepts like arrays and loops, can be powerful when you use them strategically.
So the program just keeps taking input, doing calculations, managing the array, until the user decides they're done, right? What happens then?
Well, once the user says they want to quit, there's another for loop that simply prints out everything in the last 5 result array. so the user sees those final 5 results.
It's amazing how this challenge actually involves so many moving parts. Really shows how those programming concepts all work together.
Yeah, and it's not just about the code itself. It forces you to think logically, like break down a problem and then figure out how to manage that data. Those are skills that go way beyond just programming, you know?
Like training for a fight. You develop discipline, strategy, the ability to adapt.
Yeah.
But let's connect this back to our listener. Big picture time. Why should someone care about understanding Java arrays? Even if they're not, a software developer.
It really comes down to organization and how we manage data. And that's something we all do, whether we think about it or not.
So it's about thinking in a structured way.
Exactly. Think about planning a project or your finances, even packing for a trip. It's like creating these mental arrays, right?
Yeah.
Organizing things into categories and steps.
But with arrays, you're not just organizing data, you're learning how to manipulate it. Like to make it work for you, like that shifting technique. It's almost like prioritizing, deciding what to keep and what to let go.
That's a great point. And remember what Ellie said about the right data structure. Yeah. That applies to life too. You wouldn't, use a hammer to screw in a light bulb.
Right, yeah.
Same goes for organizing information. Use the right tools, the right methods for the job.
It's fascinating how these technical concepts can actually apply to, broader things like problem solving, even decision making. It's about seeing the patterns and then applying those principles to different areas.
Absolutely. That's one of the best parts of learning, right?
Yeah.
Seeing those connections and how they change our understanding.
So we're wrapping up this deep dive. What's one big question we can leave our listener with? Something that makes them think about this more.
How about this? We talked about arrays in programming, but how could those same principles, organization, data handling, strategic manipulation, be used in something you're passionate about? Music, history, whatever.
It's taking that knowledge and seeing it in other areas.
Yeah.
You might be surprised what you find.
Exactly. Maybe it even sparks a new idea.
Well, on that note, I think it's time to wrap up this deep dive. We went from boxing to coding, and now to these bigger ideas about how we think.
It shows that learning can be, surprising and even fun, especially with the right mentors, even if they're fictional boxers.
And as always, keep exploring, keep asking those questions.
Until next time, keep your arrays organized and those minds sharp.
See you on the next deep dive.